Could this newly discovered object orbiting Earth be a forgotten relic of humanity's space race? Or even an alien spy satellite? Imagine for a moment that intelligent beings from another world have been silently observing our planet for billions of years, using tiny technological gadgets disguised as natural space rocks to monitor the rise of life on Earth. It's a thrilling concept, and one that fuels endless debates among astronomers and science enthusiasts. But here's where it gets controversial. What if our own discarded spacecraft are masquerading as these mysterious objects? Let's dive into the fascinating story of 2025 PN7, a newly spotted quasi-satellite that might just be the key to unlocking these cosmic mysteries. For beginners, think of our solar system as a vast, bustling neighborhood where Earth and its moon spin around the Sun. Over the last 4.5 billion years, since the planet's formation, could advanced extraterrestrial civilizations have planted monitoring devices in this habitable zone? These devices could resemble small, orbiting rocks that act as temporary secondary moons, keeping tabs on Earth's evolution without us ever noticing. This idea isn't just wild speculation. Back in December 1991, astronomers from the Spacewatch Project, a team at the University of Arizona's Lunar and Planetary Laboratory, spotted the first asteroid following a path eerily similar to Earth's, 1991 VG. At the time, some experts wondered aloud if it could be an interstellar probe, essentially, a probe sent by aliens from another star system. You can find that intriguing discussion in this academic paper. Eventually, though, the scientific community largely agreed that such objects are natural phenomena, part of what's now called the Arjuna class of asteroids. These occupy the same orbital region as the Earth-Moon system around the Sun, as explored in this detailed study. Arjuna asteroids with orbits very close to Earth's can sometimes get temporarily captured as mini-moons, thanks to gravitational resonances, those rhythmic pulls that sync up orbital paths. But let's clarify a key distinction to make this easier to grasp. Quasi-satellites are different from mini-moons. Mini-moons are asteroids that get gravitationally bound to Earth, orbiting it closely for a short time before slipping away. Quasi-satellites, on the other hand, aren't truly captured, they just hang out nearby, following paths that bring them tantalizingly close without being locked in. Some well-known quasi-satellites of Earth include 164207 Cardia, 2004 GU9, 469219 Oumuamua, 2016 HO3, 277810, 2006 FV35, 2013 LX28, 2014 OL339, and 2023 FW13. These are all natural rocks, as far as we know. Now, fast forward to August 2, 2025, when brothers Carlos and Raúl de la Fuente Marcos made an exciting discovery, as detailed in this research article. They identified a new quasi-satellite, dubbed 2025 PN7, which the media eagerly dubbed Earth's second moon. As an Arjuna-class object, it boasts an orbit period almost exactly 1 year, matching Earth's, but with a noticeable eccentricity, that's the oval shape of its path, of about 0.1075. This means it spends more time lingering near our planet than a perfect circle would allow. And this is the part most people miss. 2025 PN7 status, as a quasi-satellite, is relatively recent, dating back to the 1960s, a decade of monumental strides in space exploration for both the Soviet Union and the United States. They were busy launching missions to the Moon, Venus, and Mars. This timing naturally sparks curiosity. Could 2025 PN7 actually be a man-made artifact from one of those early interplanetary voyages? In other words, is it a leftover from humanity's space age? I recently posed this exact question to my brilliant colleague, Adam Hibberd, and his response was a brand new paper we've submitted for publication, which you can check out here. Using his custom Optimum Interplanetary Trajectory software, OITS, Adam calculated the paths of various 1960s missions from launch to now. We then compared those trajectories to 2025 PN7's orbit to see if any matched up. Take a look at this set of figures, you can expand them for a closer view. The top left panel shows 2025 PN7's average distance from Earth over 20 years, highlighting how it became a quasi-satellite right around the launch of the Soviet Union's Zond 1 mission on April 2, 1964. When we plotted the Sun-centered longitudes of 2025 PN7 against those of 26 Venus-bound missions, we spotted something intriguing. The Zond 1 mission showed the smallest difference, meaning its path aligned quite closely. The Venera 8 mission was a close second, though with a bit more deviation. See the top right panel. Delving deeper, the bottom left panel tracks how far 2025 PN7 deviated from Zond 1's probe during its journey. The minimum gap was about 8% of an astronomical unit, or AU, which is roughly the distance from Earth to the Sun, about 93 million miles. That's not perfect, but the bottom right panel reveals their longitudes evolving almost identically throughout Zond 1's flight. Of course, there's a catch. 2025 PN7's closest approach to Earth is only about $0.20, while Zond 1 was supposed to reach Venus at 72 cents from the Sun. So, could it instead be the Blok-L upper stage of the Zond 1 mission? Maybe the stage didn't deliver enough velocity, that's the speed boost needed for space travel, and fell short, just like 2025 PN7 did. Zond 1, you see, was a mission plagued by failures due to technical issues. Our calculations suggest the Blok-L might have underperformed, forcing Zond 1 to make an extra burn on April 3, 1964, possibly to compensate. It's doubtful the probe could fully correct for that shortfall. To test this, we estimated the Blok-L's brightness assuming it's highly reflective, sizing it up to about 3.2 meters. Which matches observations. We also compared its orbital tilt, or inclination, at launch time, 2025 PN7 at 2.44 degrees versus Zond 1's 3.42 degrees. Close enough to be plausible. In wrapping up, it's entirely feasible that 2025 PN7 is the Blok-L booster from the botched Soviet Zond 1 Venus mission. But to confirm, we'd need spectroscopic analysis, examining its light spectrum to reveal the surface material. This technique proved successful for identifying 2020 SO as the central upper stage from NASA's Surveyor 2 moon mission launched in 1966. Observations from Hawaii's Pan-STARRS telescope showed 2020 SO behaving unusually, pushed by sunlight, and NASA's infrared telescope facility in December 2020 confirmed its stainless steel-like surface, sealing its human origin. This brings us to broader cosmic puzzles. On October 19, 2017, Pan-STARRS detected another oddity, the interstellar visitor 1I at Oumuamua, which sped away from the Sun without cometary tails, as detailed in this paper. I proposed it might be accelerated by sunlight reflection in a 2018 study. Since it's not bound to our Sun, and doesn't match any known human missions, it must hail from beyond our solar system. So, who made it? Adding fuel to the fire, 2 of our 3 known interstellar objects, Oumuamua and 3I Atlas, show anomalies. This echoes in a thought-provoking message I received from Jakob Wieners, an orchestra conductor and cellist with a passion for astronomy. Dear Professor Loeb, allow me to introduce myself. I am Jakob Wieners, orchestra conductor and cellist. Although my professional field is in the arts, I have always felt a profound fascination for astronomy, mathematics, and philosophy. Like millions of people around the world, I am enthusiastic about and deeply inspired by your open and disruptive mindset, qualities that have made you a prominent figure in the scientific community, with an extraordinarily broad vision. Regarding the latest interstellar visitor, I would like to share with you a brief personal meditation. I believe it would not be strictly necessary for an advanced civilization to resort to large spaceships to explore or interact with other stellar systems. It would suffice to use comets or asteroids as vehicles or projectiles. In fact, even we, with our current limited capabilities, could probably do so through the use of atomic bombs, guidance systems,